Welcome back everyone to Learning by Teaching. Today we're in statics and we're going to be solving problem 1.2. Okay, so it says represent each of the following combinations of units in the correct SI form. We have a kilonewton divided by a microsecond. We also have a megagram divided by a millinewton, and we have a meganewton divided by a kilogram times a millisecond. Okay, so now how are we gonna solve this? Well, basically what they want us is to combine these prefixes, kilograms with microseconds, all into a single one. And in order to do that, and since we're learning, we're gonna be utilizing what they give us in this table. So if we pay attention to the table, basically this table is in the book, as you can see, it's table 1.3. Well, they give us that we have a prefix and the symbol. So similarly as like this one over here, a kilo, we can proceed and say, hey, a kilo is equal to times 10 to the positive 3, right? So we're gonna do that. Let's just start doing this problem by, well, in A we got a kilonewton divided by a microsecond, and if we use the table, well, we have a newton multiplied by 10 to the positive 3, and under we have seconds multiplied by 10 to the negative 6, and that negative 6 again come from this micro. Okay, so now that we know that, we can simplify these two guys basically by knowing that when I have a base number raised by a number and then the same base number raised by a different number, what we can do is basically take the number above minus the number below. So which in this case will end up having 10 to the positive 3 minus negative 6. Again, you will have Newton over second, and we'll have 10 to the positive 3 minus negative 6. So now that we have this subtraction in here, well, we know that minus and minus will become a plus, so we have 3 plus 6 basically, right? And I'm gonna save some space in here and put it to the negative 9, the positive 9, I'm sorry. So we're going to go back to the table and we're going to find this exponential form, 10 to the positive 9, and we will realize that this is the same as having a giga. So we can rewrite this as having a giga, not newtons per second. And just like that, we found out the first answer for this problem. We're going to do the same thing for B. In this case, we're going to do it a little bit faster. We got megagrams over millinewtons. We're going to use the table for the mega is, so we got grams times 10 to the positive 6 over newtons times 10 to the negative 3. And just similarly like we did in here, well, we have 6 minus 3, that will become a positive, right? This, I'm talking about this minus 3. So we have grams over newtons times 10 to the positive 9. And just like that, we also can say, hey, this is the same as a giga. So we got gigagrams over newtons. And this will be the solution for our problem B. Now for C, what we have is meganewtons over kilogram times milliseconds. Okay, so what we're going to do is that we're going to say meganewtons is the same as newtons times 10 to the positive 6, again by using our table. I'm going to leave kilograms by itself as kilograms, and I will explain this a little bit later why. And then we have times seconds multiplied by milliseconds. Well, milliseconds, again, milli is negative 3, so 10 to the negative 3. And just like this, we're going to have newtons over kilogram times second. And this is going to be times 10 to the positive 9 again. And this guy will also become a giga newton over kilogram times second. And this will be the answer for problem C. Now, some of you may ask, hey, why didn't you make this kilogram, right? Because this is a kilo, will be just gram times 10 to the positive 3. Well, we tend to use grams more like in kilograms. And also under the table, they specify this part by saying, hey, the kilogram is the only base unit that is defined with a prefix. So basically what they're saying is, hey, it's very normal to leave kilograms as kilograms, you know? Now, you may say, hey, but over here we lock them as grams. Yeah, it really depends. If you were to go and say, hey, it's not a giga, it's a mega newton over gram per second, if you do it in this way, well, this means the same, okay? It's just a different way. So don't get too confused about it. Just you will learn this by time, slowly, that sometimes the books and mathematics we prefer some units over the others, but that's about it. So I really hope that you guys like this video. Please push the like button, subscribe, and I'll see you guys in the next one.